Well, now let's take a look at the project mode. First of all, why would you want to use a project when you can certainly run the scanner and be able to see the graph? Project mode is going to run in the background. But there's a reason for it. Normally, if you're going to be studying a particular stellar object for a period of time, and you want to take multiple scans on it over several days or weeks or whatever, it's best to run it in project mode. Project mode can then be set up to run the start timer. The start timer can automatically turn everything on for you, capture the object according to your specifications on your settings for the commander, and the data will be stored for you over a period of time. You can come back days later, a week later, and your data will be saved for you under the same project. One of the nice features about Spectracyber RPi software is that your settings on each scan are remembered, and they're saved for you. So when you come back and you run that same scan again, all the settings will be restored exactly the way you left them the last time. So in a project mode, it's wise to leave the settings untouched after you set the first one up. Leave the settings alone, because this is a good way to do any kind of scientific data. You want to keep all of your parameters of your experiment or your data collection exactly the same, so nothing changes. So each individual scan should be a replication of what it is you're trying to study, and you're not manipulating things by changing the gain or changing your bandwidths and things like this that may not be important. Of course, the software is versatile enough that if you wish to do so, you can on your own. And each data file will have that secondary header that we talked about earlier, and that header will then show you what some of your settings are. It will not give you your gain and things like that that could be important if you're trying to do actual measurements. So it's wise in the project mode just to leave things as they are. So let's go ahead and take a look at the project mode. Okay, we're ready to start our first project. So go to the commander, click on File, click on Project, come over to New Project, and click on New Project. Project window shows up. Now by default, the project name is set to temp for a temporary project. You can change this name. I'm going to go ahead and use temp, but this will be the temp file. The project temp file will be saved in your working directory down here. And it will be given an extension of .prj for the word project. Now you can go ahead and fill in the researcher. I'm going to type in just me. And then there's a description box which you can put in a 64,000 characters, but it would be better if you just type in some kind of a few brief statements here, a few sentences long, just to describe what your project's all about if you desire. You can leave it blank, of course, if you don't need that. Over here on the stellar object, you can then enter a stellar object. You put in a catalog number. That can be any kind of a catalog number, alphanumeric type characters. Try to keep it simple. At the same time, you should put in the object name, flux density. If you know it, it's defaulted to 0. The right ascension and declination, and of course the object type. Now as an option, if the database is already populated like it is below with a few samples, you can just as easily fulfill all of these screens up here by simply clicking on the number on the side. I'm going to check Cassiopeia. So let's click on that, and you see it all got populated. All the numbers are there taken out of the database, so we didn't have to do anything. So the project's ready to go. Now by clicking on OK, project should be created. Let's see if it is created. We go back to the commander. Under File, Status, we click on it, and you see now that the status is open. It's a project. It's named Temp, and all of the settings on the control screens here in the commander have been saved for you, and they will be saved along with the project in the project subdirectory. Also, when the data is saved, the data will be saved in the subdirectory as well, and each file name will be given exactly the same name as the subdirectory. That's why the word temp is being used here. This should be something simple, because there will be a numeric number added to the end of this word temp, to identify each file that belongs within that subdirectory, so you can pick up a particular file at any time later on. So we're going to click OK here. Now all the settings are preset. We've already done this before on the scanner. So now in order to get your first scan, we simply click the scan button. Now it'll scan, and as it does, you'll see that over here on the signal status, the status bar is running, showing you that approximately how long it's going to take for it to be completed. In the meantime, you will see no graph. This runs in the background, allowing you to do other things. So if you're doing an awful long scan or taking a lot of data, you have the luxury of going back into the Spectracyber RPi main application, and you can do plots of other data, analyze other data in the meantime, while you're collecting the data on this particular object in the background. So it's a very powerful feature. Just keep in mind that all of this is working to save all the data for you. So the temporary file where the data is being stored will then be renamed and stored in your project directory. So you will have 2 copies at that time. Every time you do another scan, the temporary file will naturally be overwritten, but it will then be saved underneath the next numerical number within your project directory. So this gives you the ability to go ahead and use the start timer mechanism that we described earlier in other lessons, so you can set up a target time of when you want the write ascension to be captured, and then go ahead and enable that start time and come back several days, a week or so later. All of your data will be saved each day if you've set it to run every day. To repeat, it will repeat collecting the data on your behalf, and you totally unattended for a week or more, whatever length of time you wish, and the data will be done. Now you see it has completed. So let's go ahead and see if it's been plotted. Let's take a signal plot on it, and we'll do a minimum. We'll see it in an expanded mode, and here it is. There is our data. Now of course this isn't actually the galaxy itself. It turns out that we're at only 13 hours, and this is not the same write ascension. My antenna is pointed elsewhere, but this is a sample to show you what you would get. So we can close that one, and that's basically it. Now back over here, you've got the same thing. We can click on plot. Remember, it was now plotted. The data was plotted. I'm going to click write ascension. The data was plotted into the temporary file. It's also stored in your temp directory. There's the temp directory. If I click on the temp directory, there's your data right here, along with the settings that were saved from the main screen. The reason these settings are saved is so the next time you come back in, all you really have to do is open the project up, click the scan button, or set up an automatic start timer, and all that data will be taken for you using exactly the same settings from one day to the next, which is really a scientific method to do that. Click on the sessions here and get back to projects. The screen gets a little squirrely, but anyhow, that's basically it. Of course, you could plot the data, you can fit the data, and all of that. So if I go and let's take this and go back in, and let's plot it right ascension, and that's going to be it. We're going to go ahead and close this out. So let me finish. All right, there we go.